In this second video on sequences, we're going to have a look at physical situations leading to these sorts of sequences. So each of those lines represents a match. So if we're looking at this first one, one square is made up of 4 matches, 2 squares is 8 matches, 3 squares is 12 matches, and so on. So the first bit here says, draw the pattern needed for 4 squares. So, 1, 2, 3, 4. Okay? So if we're doing 4 squares, you can see there would be 16 matches. So that'd be the fourth one. It follows on from that. Then they've given us the sequence of the number of matches, which has gone 4, 8, 12, 16, and asked us to continue it for 3 more. Okay, copy and continue it. So it goes 4, 8, 12, 16. What are we doing? We're going up by 4 each time, aren't we? Look. Goes up by 4 each time. So the next one's 4 more than that, which would be 20. The next one's 4 more than 20, which is 24. And the last one's 4 more than 24, so 28. They asked for the next 3, these are the next 3 in this sequence. Okay, it says copy and complete the next bit, so I should really write this all down again. It says start with 4 matches for 1 square and add on, well, that's what we were just doing here. We're seeing it's adding on 4 matches for each extra square I add. Okay? Next bit, it asks me how many matches are needed for 10 squares. Well, look, that's 1, 2, 3, 4, 5, 6, 7. That's the 7th one. So the 8th one would be 4 more, which is 32. The 9th one would be 36, wouldn't it? And the 10th one would therefore be 40. So, just continuing the sequence onwards, 32, 36, 40. That's our 10th term. So that's the one we needed for 10 matches. Sorry, for 10 squares. You need 40 matches. That's our first example. The second example we're going to look at today is something called the Fibonacci sequence. Okay, it was way back in medieval times, there was a monk who came up with a particular sequence which he thought described how rabbits reproduce. But anyway, I'll show you how this sequence works. You can research it if you're interested. Basically, for any Fibonacci sequence, this is not the same one as they're going to ask you to have a wee look at, but if you start with 2 numbers, okay? The Fibonacci sequence says that the next term is the 2 terms before it added together. So that one is going to be 2 plus 2. Okay, so it was 2 plus 2, giving you 4. And we keep doing that. So if I wanted the 4th term in the sequence, I'd need to add the 2nd one and the 3rd one together. So that would be 2 plus 4, which is 6. Okay, and then if I wanted the 5th sequence, what I'd have to do is I'd do the 3rd and the 4th added together, which would be 4 plus 6, giving me 10. And it goes on forever, this sequence. So basically, you add the 2 terms before to get the next one. So let's go through that again. 2 plus 2 gave me 4. 2 plus 4 gave me 6, and so on. So if I asked you, what is the 8th term of this Fibonacci sequence. I just have to keep this going, yeah? So we've gone 2, 2, 4, 6, 10. That's what we've got there. See, 1, 2, 3, 4, 5, 6, 7, 8. I need to get up to there. So we know the next one would be 6 plus 10, so 16. The next one would be 10 plus 16, which is 26. And the one I'm actually after, the 8th one, would be 16 plus 26. Okay, 32, 42. So the answer to that would be 42. Okay, so that's how the Fibonacci sequence works. Okay, this isn't the same one as they've got for the last question you're asked to do on today's worksheet. The one they got on the worksheet starts 1, 1, but you do exactly the same thing. You add the previous two terms to get the next one. Okay, so the third term's the first and second added. Yeah, the fourth term's the second and third added, and so on. Okay, and that, as I said, it's got a special name, named after, I think it was 13th century monk, something like that. Fibonacci sequence. Okay, you should now be able to do today's questions.